We talk about the cofunction identities, and we've actually seen these before. We've been quizzed on these and tested on these before. I think the formulas, though, are kind of complicated to look at. It looks a lot more intimidating than it actually is. When we talk about the cofunctions, sine 50 degrees equals cosine 40 degrees. We've talked about this, and I think you understand this. If I said tangent 20 degrees, that would equal cotangent 70 degrees. We know that cofunctions have this property that their angles are going to add up to 90. Cofunctions, angles add up to 90, and that's what all these formulas say. It's just kind of hard to look at. That's what they say, though. So secant 30 degrees equals cosecant 60 degrees. Okay, what are cofunctions? Sine and cosine. Tangent and cotangent, secant and cosecant. Those are cofunctions. And so when we look at example 2 down here, cotangent theta equals tangent 25. You probably should be able to do that in your head. It's going to be 65. Because we know those are cofunctions, and cofunctions arguments add up to 90. Theta plus 25 equals 90. We subtract the 25. Theta equals 65 degrees. I think you should probably be able to do that in your heads, though. Part B, same thing. We're still using cofunction identity. Sine theta equals cosine negative 30 degrees. Okay? A little bit harder because of the negative, but we know that cofunctions have this property where their angles add up to 90. So we add 30. Theta equals 120 degrees. The radians is a little bit harder. They were just not as good with radians, but we're also going to have to deal with fractions. But radians acts pretty much the same thing, the same way. I forgot to point out over here, similar identities can be obtained for 90 degrees when you use pi over 2. The radian equivalent is pi over 2. And so when we do example 2c, and we see these two things are cofunctions, instead of saying those two angles add up to 90, we would say in radians, those two angles add up to pi over 2. And so it's really the same thing, it's just a lot harder to do in your head. I'm going to solve that equation for theta. So I'm going to subtract 3 pi over 4. But when we subtract fractions, I'm going to get a common denominator. So let's call this 2 pi over 4 instead of pi over 2. So let's just subtract 2 pi over 4 minus 3 pi over 4, and you would see that theta equals negative pi over 4. Down at the bottom it says these are periodic functions. And so what that means is if you added 360, you're back in the same place. Add 360, add 360. Or in radians, you add 2 pi, add 2 pi, add 2 pi, you're back in the same place. And so what that means is there's maybe more than one answer. Okay? Infinitely many possibilities are given. We just found one of those answers.